been out for, I don't know, 3 or 4 years now, maybe a little longer than that. And it was released and designed to be a replacement for traditional ZoneTight valves. Some of those might be, you might like the Erie top valve was very popular for a bunch of years. Calefi makes those types of things. Almost every company either makes one or sells one, and they're generally considered lower performing devices and lower quality devices, but they're also low cost devices. So there's kind of a trade-off on that. What we attempted to do here at Belimo is create a valve that was indeed a nice small package forming device that kept the price point very competitive. And so let's go ahead and take a look at the Belimo ZoneTight. They are typically designed for low flow applications, so we see them in some of the applications we see here, like thin tube or fan coils. Maybe to a lesser degree, chilled beams and radiant cooling, definitely in our reheat coils on VAVs, those types of things. The ZoneTight is designed to fit most hot water and chilled water applications. You can see here it will do water anywhere from 36 degrees to 212 Fahrenheit, and it has a nice robust body pressure rating of 360 psi. Again, in these types of applications, we would be unlikely to see pressures that high. You'll also notice on the Belimo next to the picture of the two different types of zone valves, that we have the Belimo 5-year warranty stamp. And I'm going to point that out a few times because it's relevant. We had a 5-year warranty on our ZoneTight valves before. And in general, it is a good indicator of how we feel about of any product. So if you're familiar with our new PR series butterfly valve actuator, that would be our first butterfly valve actuator to ever carry the 5-year warranty. And indeed, the ZoneTight does as well. And so that means for us that we feel that this is a robust and strongly designed product, and we're willing to stand behind it with a full year warranty that we product. The other thing, that there's a kind of standard ball valve looking thing on the right there, which is our standard ZoneTight QCV valve. And then you'll notice that there's with a couple of pressure ports in it. That's going to be our PI QCV, and that is a pressure independent ZoneTight valve. So we're going to spend most of this presentation talking about the standard QCV ZoneTight zone valve. But there's a few slides at the end. We'll talk about the PI QCV, and I absolutely invite you to reach out to Belimo if you want to get a lot more education about the pressure independent series. Belimo, obviously a big proponent of pressure independent valves in the marketplace. Let's take a little bit more look at these two different products and where they fit. In applications are overlapping between the QCV, which is pressure dependent, the QCV, which is the pressure independent version. Again, all good on fin tube and fan coils, VAVs, chilled beams, and radiant, like chilled ceilings and things like that. The PI QCV is also available with a dial flow setter, and then this product can be used just as you would a flow limiting style balancing valve. And so that's sort of a unique application as well. Let's go into a little more deeply, and let's try to make some differentiations between what this product is and what the standard ZoneTight valves would be. So obviously, a pressure-dependent valve. It's available in 2-way and 3-way valves. It's available with threaded fittings or sweat fittings. It has a nice high close-off pressure of 75 psi. The ZoneTight valve is indeed a ball valve on the inside, so we're able to create nice high close-off pressures. They're extremely low power consumption, 0.3 watts per. It's just tiny compared to what else is out there in the industry. And again, we're going to carry that 5-year warranty. So we want to make a zone valve a nice small product. All zone valves are relatively small. We want to put them in tight spaces. We went even smaller with this QCV. So you can see here, it's ultra compact, 3.5 inches tall on a three-way valve. Just as an example, a more traditional type zone valve you'll see are here on the right side of the screen, a full inch and change taller, both on the two-way and three-way valve. And then just imagine trying to cram that into a place where you're putting in some baseboard heat or other types of fin tube. Those cabinets or little areas are quite compact, and so this smaller valve is quite handy. It also has an integrated half-inch conduit connector, which is unique, and it also comes with its own furnished plenum cable. So that's unique for zone valves in general. Usually they have maybe a couple of loose cables, certainly no conduit, and sometimes no wiring at all. So that's the overall size of and features. When we look at the valve itself, the QCV, as I said, is simply a nice ball valve. We have stolen some of the design principles of the CCV, or the characterized control valve, which is the control valve that Belimo's been selling since the late 90s based on ball valve technology. Most specifically, you'll notice on the stem that there's the double O-ring design. This helps obviously keep the water in the pipe, which is where we want it. We also have the Teflon seats on the left and right side of the ball, and that's what allows us to get the nice high close-off pressure. Traditional zone valves use a much less expensive type of valve. We call these flapper valves, or there's a couple other names for them, but basically that little black circular piece that you see there is connected to the stem, and the stem rotates maybe 30 or 40 degrees. So it's just like a little door, basically, that opens, and then the water can come through. And then in order to get close off, that rubber flapper has to push pretty hard against that opening, and that's why traditionally with these types of valves you don't really have pressure, because that's a fairly inefficient way to try to create close off. So with the QCV technology, we're getting that nice 75-pound close off pressure. We have no leakage. Traditionally with zone valves, we have ANSI Class 3 close off. If you're not familiar with the ANSI scale, don't worry about it, but basically what that means is that you get 0.1% leakage even at full close off. So one droplet of water out of 1,000, which doesn't seem like a lot, but it certainly isn't bubble tight, and over time it's wasted energy or possibly other issues there. So we're going to eliminate that by having the zero leakage. And then the nice part about a ball valve is that when that valve is open, there's almost no obstruction for the water. So if there's some junk in your water, maybe there's some Teflon tape floating around in there, you can see how if that flapper opened up a little bit, the tape could get wrapped around the paddle, the flapper, and it's just kind of in there. With the zone valve being based on the ball technology, just as it was with the CCV, those valves are essentially self-cleaning, and all that means is if it's clogged up a little bit, it'll open more based on the control starving the space of temperature, and then whatever's there will pass the ball valve, and then we can go back to traditional control. So that's a good design there. If we take a look at the actuators, Belimo has developed a new series of actuators, the QC actuator here, and then the QCK, which is the supercap fail-safe version of that same actuator. So these are a nice little actuator that we've put together, and this would be your traditional one like we saw in the previous slide. Those types of motors are not quite as technologically advanced. So what we're going to do with the QC and the QCK motor is we're going to implement our patented brushless DC motor technology. This is the same type of motor that we put in, the LM series all those years ago, when we took it from something that regularly had motor faults to something that was almost bulletproof from a quality standpoint. So we love our brushless DC motor. And then we use the traditional style multi-stage gear train that Belimo is so fond of, that we've had so much success with. This allows us to use smaller motors with lower amp draws to create higher forces and higher torques to open and close the valve. Traditional zone valves, as you'll see here on the right, use a pretty big motor that's in there. It's hard to see, it's wrapped behind all those cables. And then they just use a single gear. So the motor turns that gear, which then turns the stem Sometimes there's the second gear in that stage, but you can see the whole thing is open to air. There's just a bunch of grease globbed onto it, and it's just a much less robust type design. Because we need that bigger motor, because we're not using a multi-stage gear train, we're going to use a lot more power. That 0.3 watts is tiny. Usually we're looking at 3, 4, 5, 6 watts per one of these units. So to use 0.3 means we're using just significantly less. And then the other nice part is that the ball style valve is not susceptible to the sticking that we see sometimes in those types of zone valves. So what I mean by sticking is that valve was in a closed position. The spring activated and shut it closed, so we were closed off. And then we turned that off, for, that mode of, let's say we turned the heat off all summer long, so that valve's closed the whole time. And valves, sometimes when they go to open, when we change back to heating, that valve will get stuck. That rubber has deformed around the opening and it kind of gets stuck there. Obviously none of those types of things go on with the ball valve. So we're using just a much superior valve technology and a much superior actuator technology. On our actuator, we said we have the super cap version versus the standard one, and then within each of those we have the on-off or floating style actuator. So that would be your here on the the CQB, and then we modulating, and so the modulating would be your proportional 2-to-10 style actuator, and then we have that one pictured there is actually a fail-safe version, and so you can buy one for fail open or fail closed. In general, from the valve offering, if you were to inventory the entire product line, you're only looking at these 12 valve bodies. So we have 3 valve bodies in 2-way and 3 valve bodies in 3-way, and then obviously we have the NPT and the sweat, so you have 2 versions of each one, and that would give us a dozen different valves. On each of these, there's 2 sizes in the 1/2 inch and then 1 3/4 inch valve. So on the 2-way we have almost 10 CV, which is a pretty big flow rate, and then on the 3-way valve, that 3/4 inch, based on the geometry of these valves, creates a whole lot less flow. That would be a 4.6. Now those 3-way valves are just 2 position. They're not designed to modulate, so those are changeover 3-way valves, just as we would use a traditional zone valve the same way. Just a little competitive analysis. The QCV, now if you remember all the way on the right of this slide, you'll see the Belimo zone valve. So that's a zone valve that we sold for a few years through OEM supplier. So that's that guy. And then there's a few other different ones from the marketplace, and you can see that we use a ball valve. Only one of these other guys is actually using a ball valve. Everybody else is either using that flapper style valve or a short stroke globe style valve. You see a lot of intermittence in terms of how much close off you're getting. The claim that one of those flapper valves is 100% bubble tight is questionable as far as I'm concerned, but apparently that's what's listed in their literature. Get the nice high close off pressure, really low comparative power consumption. Look at some of those power numbers: 6.5 watts, 5 watts, 3 watts. When we're at the 0.3 to 0.6 range, that's an enormous less amount of electricity needed to power these things and operate them. One nice part about the QCV that's completely unique from everybody else, you have a field adjustable CV rating. So you're going to go and buy one for a certain CV rate. It's field adjustable to have a lower CV rating, and so that gives you a lot of flexibility in your valves, and obviously the 5-year warranty. I'm going to take just a couple of minutes here and talk about the pressure independent version of this valve. This is the PI QCV. As you're probably aware, most of the letters in Belimo don't mean much, but QCV actually means quick connect valve, in case you were interested, and then the PI version means pressure independent. So the PIQCV is a zone level pressure independent valve. So it's a control valve with an integrated pressure regulator in it. And basically the way that the pressure independent valve works is the regulator ensures that the pressure drop across the is always a constant number. And so if we know the pressure drop off a known opening of the valve, we can predict very accurately how much flow is going to go through that valve. So we always say that a pressure independent valve is a two-way valve that supplies a specific flow for each value of the control signal regardless of pressure variations in the system. So we often think that if we open a valve halfway, we're always going to get a certain amount of flow, but the reality is that if we open the valve halfway and it's pressurized at 3 or 4 psi, we're going to get a certain amount of flow. But if we leave it in the same exact position and there's 15 or 20 psi pressure drop at that valve, we're going to get a significantly higher flow. This is the thing that pressure-independent valves will take out of play. Interesting note regarding pressure-independent valves is that in general, pressure-independent valves do not require any balancing device. And so the cost of the valve itself is at a little bit of a premium. If you start to look at the cost of replacing a control valve and the balancing device, then the pressure-independent valve oftentimes for the PIQCV will actually be a less expensive solution than using a traditional design. A couple, just a few overview things about the PIQCV. First of all, you can see there's a cutaway here on the right side of the screen. If you're a little bit nerdy and wondering exactly how this valve works, then A, you're my type of person, and B, you're going to enjoy the next 30 seconds. Everybody else, feel free to tune out. But basically, the water comes from the right side, so it goes right to left through this valve. And that spring-loaded area inside of there is the pressure regulator. And what happens is it is reacting dynamically to pressure differential across the ball of the valve. So the higher the pressure drop across the ball of the valve, the more pressure drop the regulator will try to absorb, which drives that pressure drop of the ball back down. So it stays at a constant level. And then obviously on the left side of the valve, you can see there's a little ball valve there. That's actually a characterized ball valve, so it's just like your CCV. And just like the other ZoneTight, you can see the dual O-ring design in the stem, which keeps the water in the pipe, and that becomes your control valve. So you put a little valve operator on top of that stem, you put a motor on there, a little QC or QCK type actuator, and you can modulate. Or like we saw earlier, you can put that little handle adjustment on there and just set the valve to a specified position, and then it behaves just like a flow limiting valve. So you can set it for 2.5 gallons a minute, and you'll never be able to cram more than 2.5 gallons a minute through that valve. So we did build all of our ZoneTight series on the CCV technology. This particular valve has an even higher close-off than the standard ZoneTight. So this is 100 PSI close-off, bubble tight. Also has low power consumption. It's very small. If you compare this PI version versus the old series PI CCV, if you remember that valve, it kind of looked like a Y strainer, had that nickel plating on it. It was a good looking valve, but it was pretty big, and we would put that LR series motor on top of it. This is about half the size of that. This also has field adjustable flow and carries Belimo's 5-year warranty. The product line is a lot simpler. There's the fail-safe and non-fail-safe motors, and there are 4 valve bodies. So there's 3 valve bodies in the 1/2 inch size, and then 1 3/4 inch. And then you can see the GPMs for all of these listed on the left. If you're not familiar with pressure-independent valves are sized and selected but simply by the G oil. So you don't need to know pressure drop, and you don't need to calculate flow coefficient. Whatever the GPM is, that's the valve you need. And all of the flows in that chart there have asterisks next to them because that is the maximum flow of that valve. and each one of these valves, just like the standard ZoneTight, can be field adjusted to a lower value. So just as an example, if you were doing a VAV reheat, a lot of times we'll see requests for 0.5, 0.6 gallons a minute on a reheat coil. Well, we could buy that dash B version of the valve, which is 0.9 gallons a minute, and then reposition the end stop on to adjust to a lower value at that 0.5 gallons a minute or so. So that gives us a lot of flexibility, and certainly you guys as distributors can deliver the exact product somebody needs, even if the design valve's slightly larger than what they need. We can reconfigure it so that it's exactly what they need. And that's not just true for the PI-QCV. I think I said this before, but I want to make sure it's real clear to everybody. This is true for the standard QCV, the standard ZoneTight, or the PI version. Let's take a look at how this works, and we're going to show you with graphic of the actuator on this cutaway here. This actually comes right out of the installation instructions, like right out of the box that this comes in. So this comes with every valve that shows you how to do this. The chart at the bottom is for the PI QCV, but we have a similar one for the QCV. So we're going to take the type D valve, which is a 1.9 GPM valve, and let's say we want to run it at 1 gallon a minute. And so we would say we would look at our chart here and say we want to go to 1 gallon a minute, and that is clip position 6, which means absolutely nothing to you guys at this point. But if you take a look at the graphic there, what they've done in the top left, there's the actuator, and then they flipped it over. So they're looking at the bottom of it, and you can see there's a little gauge on there with some numbers, and then it shows you how to pop that clip up and put it in the right position. And this is a little picture of the bottom of that actuator. So in this case, we would just go roll that clip out and line it up with position number 6. And that would allow us to get 1 gallon a minute through that valve. Now there's one more step depending on what type of actuator you have. If we have a floating point actuator, we're going to look at the bottom of this chart here and see that that new position will modulate in 62 seconds. And so your control guy is going to need to know in a floating application what the runtime is for a given valve. So as we move that clip position, they'll have an exact idea of the runtime, and they can set up their floating algorithms. If it's a true modulating application like 2 to 10 volts DC, we simply put that clip in the new position. All of the SR versions of these actuators, meaning the 2 to 10 volt modulating, have adaptation buttons. You push the adaptation button, that valve will modulate itself all the way open until it hits the end stop, and then it will reconfigure its voltage in that new smaller band. So you still get the full 2 to 10 volts resolution on your control signal, even though you're modulating through not the full 90 degrees of the control valve. We have both for the standard QCV and the PI QCV a handful of product accessories. So we'll just lay them out here so you can know what they are and decide whether they're things that you may need. The stem adapter, or this stem extension, is probably a better word for that. It just makes the stem a little bit taller, so that actuator snaps right on top of the valve that you have there, and it gives you a little more clearance for your installation. We have what we call an architectural cover. All those actuators are bright white, which we think is lovely, but maybe your customer doesn't want them to be bright white in some sort of exposed space, and so we have a little white cover that slides over and snaps into place such that the orange is covered up. We also have the orifice flow device. This is a little device that you could pipe on to either valve, and it allows you to read pressure differential across this device in case you needed some sort of flow measurement. And then we also have the flow setter. So this is specifically for the PI QCV, and that's the one where we put it on top and be able to dial up certain manual position on the control valve to achieve certain flows. We'll take a look at the installation features of this product. So this might be something you would talk to your customers about how simple this is. It is literally a snap-in-place actuator. So if you haven't seen this, there's a little, I guess a recess on the valve stem, and the actuator pops down on top of it, and there's little tabs that grab underneath that. So you just push it down until it clicks and it'll stay on there. And they're designed to flex enough that if you pull up with about 5 to 7 pounds of force, the actuator will pop straight off of the actuator. So this actuator obviously is quite compact. We just talked about that snap-on, snap-off feature, and that is for both the QCV and the PI-QCV. And an interesting function of that is if you pop the actuator off, you can actually use the actuator as a manual handle to turn the valve. So if the valve was modulated to an open position, but you wanted to set it manually closed, you could pop the actuator off, rotate the valve 90 degrees, and then it would be closed. We also have, from an installation standpoint, the field adjustable CVs or GPM. Man, I spelled GPM wrong. How do you spell a 3-letter word wrong? I spelled GPM wrong. Please forgive my misspelling there, but that's what we're looking for. And the fact that they're field adjustable eliminates the need for having a bunch of different valves. So if we needed nothing but like 0.5, 0.6, 0.7 CV valves, you know, we could send out a QCV with a CV of 1, and then we could modulate those, or rather reset them, whether they were modulating or floating, to the known CV. But we could start with just a big box of the same exact valves and set them in the field. From an operational standpoint, this might be more of interest for the building owner, whoever's going to maintain this space. We have the self-cleaning ball valves. We have close-off pressures between 200 psi. I told you 75 to 100 before. Apologies. Zero leakage, because we have the nice tight close-off, and the really low power consumption. That 3 to 6 watts that we get, the 6 watts would be on the super cap version, and that would only be when the super cap was charging. 3 to 6 watts is just 0.3 to 0.6 watts is just tiny, and when it's not operating, it takes almost no electricity. Keep in mind that if on a traditional zone valve, if you drive it to the full open position, it constantly is under load trying to keep itself open because it is a naturally spring-closed device. In this case, the valve just modulates to that full open position, and it's basically sitting there waiting for its next. I wanted to take just a minute here. I don't actually have a slide on this, but I might put one in if we do this one again. I keep talking about the super cap version, and we want to explain what that is. So because this actuator is so tiny, it seemed not real plausible to design a true spring return where there was a spring in the actuator. And so we've used a technology we use quite a bit, for example, in our energy valves and electronic pressure independent valves, which is the idea of an electronic fail-safe. So we'll build an actuator that has the supercapacitor in it, and the way that it works is when the power is removed, the supercapacitor will continue to power that actuator, and it will drive to a prescribed position based on how it is designed to fail. And if you need or want that traditional fail-safe or that traditional 2-wire type wiring that you see in zone valves, where you basically give it a hot and common and then just cut the power to close the valve, that can be done with this super cap actuator, except we don't have to fail it to close. We could fail it to open. We can do it however you want. It gives us a lot of versatility. All right, let's keep rolling here. Just from an inventory standpoint, we talked about this before. We have the 1/2 and 3/4 inch 2-way and 3-way valves, and we have the NPT and sweat. And if we make all those different combinations together, that winds up with 12 types of valve bodies. And then from the actuator standpoint, we have the on-off and modulating. We also have a UP version, which you may or may not be able to need to carry. The UP is the universal power, which means it can be powered with 24 volts or 120 volts, and You're not going to blow it up either way. Fail open, fail closed versions, and so that winds up with being 8 versions of the actuator. So you only have about 20-ish total parts to inventory, but you can create over 80 different configurations of these valves. And again, this is specific to the QCV. We would add more part numbers for the PI version as well, but those actuators would be the same, and then there's only 4 PI QCV part numbers, so you're only looking at 4 more part numbers to carry that whole product line. We have put together some nice promotional items that go with it. I really like the zone valve display on the right-hand side. It's got the touch screen and a couple of samples of the valve, which is real nice. We also have the aisle headers with ZoneTight and a handful of other promotional items, including documentation and pamphlets on these types of technologies. And then before we go, I just want to remind you why you guys do business with Belimo and how that applies to ZoneTight. Just like everything else, we have super fast delivery on these types of products. We keep large inventories in both of our locations, one of which is in the northeast part of the United States in Connecticut, the other which is in the western part of the U.S. in northern Nevada. And so we're able to ship to a lot of places in 2 to 3 days with standard ground shipping. We also continue to be a market leader in quality with our precision engineering, which we have put into every aspect of the ZoneTight and the 5-year warranty. We've improved the field operation. We've made the field selectable settings for both flow coefficient on the QCV and flow rate on the PI QCV, the snap together type solutions, and we continue to have the same type of support. So everybody has a local sales manager in their local market. We have teams of application consultants, which is what I do, and field support engineers, which are the guys we send out when there's quality problems in the field, and we continue to have world-class training, technical support, and customer service, and I hope that as I read all of these things, you guys were nodding and not shrugging or groaning. If you're shrugging or groaning, I need you to call your local rep, need you to call Belimo Corporate and let us know what we're not doing right, because we want to do it better. So at this point, I'm going to take a look and see about, actually we're going to bring my colleague Lisa in. She's going to take a look at the questions that may have or not have come in, and we'll close out from here.